So hi everybody, thank you very much for having me. Just for me to judge, how many of you know what we do at CERN? Ah, fantastic. So my communication colleagues do a good job then. Very good. So this is a picture taken from inside the Large Hadron Collider, which is our flagship research facility. As you can see, it is a tunnel, and you can see that at the end it bends to the right. That's because our accelerator is actually a circular collider. So the job that we're doing at CERN is to collide protons, but it is a fairly big accelerator. If you know a little bit about Geneva, you've got here Lake Geneva. This is the airport. In red, you've got the border between Switzerland on that side and France on that one. And this line here is the footprint of our accelerator. It is 27 kilometers long, and it is buried 100 meters underground. And so what we're doing in this particular tunnel is accelerating protons to about the speed of light. So you have to imagine one beam of protons going clockwise and another one going counterclockwise up to the point where we collide them. The CERN campus is actually on the border with, between France and Switzerland. So it is like a little entity, independent entity, dedicated to the field of particle physics. So we are the largest lab in that field, and the goal of the organization is very fundamental. It's to understand the fundamental laws of physics. So I'm going to touch on a few topics. First, the research at CERN. So first of all, when we talk in our jargon about experiments, this is what we call an experiment, right? So this is one of my colleagues, and this is the Atlas detector. So you're looking at something that is very, very big, which is not intuitive, because what we are trying to detect are particles that are very small. However, these particles are very hard to stop. Therefore, you need to put a lot of material to have a chance for this particle to leave a signature of their presence into our detector. So, in a nutshell, what we're trying to do is to investigate the laws of physics deep into matter, even smaller than quarks. To do that, like if you remember, there was a discovery of the Higgs boson a few years back, we need three things. We need an accelerator, which is going to accelerate the two beams of protons. You need a detector, or like a 3D camera, but super fast. And then to analyze the data or the pictures taken by this camera, you need a very significant computing facility. So just to illustrate how this field of fundamental research actually yields a lot of innovation, let me take you through this slide, which is about one of the 3,000 or more magnets that we have installed in the LHC tunnel. Each of these is a dipole magnet. It is keeping the particles in orbit around the 27 kilometers of the accelerator. Inside it, you have the two beams, and you've got these coils here that are bending the trajectory. These are superconductive coils. The entire volume of these blue vessels is actually filled with superfluid helium, so minus 273. So for people in engineering, you already have a lot of exciting topics to research here. Once the beams are accelerated, they will collide, and they will collide in 4 locations. On the Swiss side, they will collide in Atlas. On the French side, they will collide in 3 different places, but today I will really speak about the CMS collision point, because it is in that location that Saudi universities have been working with us. When the collision takes place, you've got the famous E = mc squared, so the energy of the incoming particle is being redistributed to give rise to new matter. And this is what our detectors get as an output when they take a picture. So here is the collision point. You see the trajectory of particles as lines, and you see little cubes like this that represent the energy that was deposited in the detector. When you compile all this data together, you get a data set. A data set is about 2 megabytes. What is, I think, very striking is that we are creating 1 billion collisions per second. And each collision, each event is 2 megabytes. So you understand immediately that we can't possibly store or analyze that amount of data because we are running 24/7, right? So very quickly, we need to go from 1 billion collision to only 1,000 events or data sets stored on tape, right? So this is a dramatic filtering of the data. And this is an area where there's a lot of computing involved, AI on FPGA, but also super fast electronics. The next step is to look at this data set that we've saved. And here I would like to introduce the WLCG. It is a grid that includes all the partner universities of CERN. So the data is stored in Geneva. This is what we call a tier 0. And then the data is being sent to secondary computing sites that we call tier 1, 2, and 3. This is a big, consolidated, this is a big computing facility with 1.4 million cores, and it's 1,000 petabytes of data stored worldwide. So you're looking at a massive infrastructure, and our partners are welcome to participate to that computing effort. So CERN was created in '54 as it was introduced. It has now grown since then. We recently welcomed states like Brazil. Saudi Arabia at the moment is not a member state, but we have an international cooperation agreement with Saudi Arabia, which allows us to transfer technology, but also to implement some mobility schemes. Now, let me go a little bit more into the details of what CERN has to offer for the Saudi scientific community. First of all, it is important to remember that your region was a cradle of science, so it's no surprise that now we are working together. And we can do a lot. This is a map showing the list of countries in the Middle East we are involved with. So you will see that we have quite a lot. In Saudi Arabia in particular, we have collaboration agreements with the KAUST and with EFET, and we are negotiating with other universities to come and join us. In 2023, there was a CERN exhibit right here on the other side of that building, and that also started to raise the awareness for the opportunities that we have to offer. I'd like to remind you also, because sometimes this is a well-kept secret, that you guys have in your region, in Jordan, a lab that is a sister lab of CERN called Sesame, which is a light source, which is very useful when you want to do material science, right? So, of course, there are other facilities in the world, but this one is really close to you guys. Let me touch on technology and innovation. So, CERN is carrying out the sort of experiments that require equipment that is not available off the shelf. We cannot buy superconductive magnets from industry, which means that we constantly have to develop these technologies ourselves. So we are innovating all the time. And because we are non-profit, because we are open science, these technologies, once we have brought them to the level where they are at a sufficient state of advancement for us, we pass them on to our partners. So today, we have technology transfers in the field of medical application, aerospace. We're working with Airbus on some projects, automotive environment. And this is, in fact, I think, building on the legacy that is the World Wide Web, which was created at CERN, not because we wanted to develop an internet, it's because our colleagues from the scientific community were getting really fed up to have to carry their data from one building to the other. It's a large campus, so they thought, instead of jumping on my bike and bringing a tape to my colleague 500 meters away, why don't I interconnect computers? And this is how the web was built. Now, education and training, so very relevant for students. At CERN, we have over 3,000 PhD students, so it's, again, a very large campus in many different fields, physics, engineering, computing. We have 600 PhD theses that are defended every year, and every summer we welcome 300 students for a summer program of 8 weeks from, well, sometimes over 101 nationality. So we have on campus a wide range of disciplines that can be used either for students or even for faculty who want to broaden their horizon. And I just put a few there, but you know, detector design is in fact related to a lot of disciplines in itself, whether it's data acquisition or material science. A lot of AI, of course, but also quantum computing, and I will touch on that in a minute. Now, we are welcoming every year interns to CERN, whether they are bachelor's, master's, or PhD students. The two latest students we had from Saudi Arabia was Wahad, who was doing an internship of 1 year from KAUST, and still today, if you can even see her at the booth on the other side of that wall, you got Aya, who is working on computing inside the CMS trigger system. So, and she is from EFAT University, so the other university. These sort of opportunities are open to all our partner universities. I wanted to show you this slide because you can see how sad and mistreated our summer students are. They're really having a hard time when they come to CERN. So it's 8 weeks. Every morning they get lectures on science. So it can be physics, it can be computing, it can be vacuum technologies. We also have guest speakers. It can be CEOs of the tech industry, astronauts, or even a philosopher. In 8 weeks you don't get to a publication, but you can do some quite cool stuff. So this is a little robot that was 3D printed and which is magnetic field tolerant, designed by a team of a Lebanese student and a female Saudi student. Now, so this is, we saw the research aspect of CERN, we saw the education opportunities. Now I'm going to spend a few slides on a brand new initiative, which is the Open Quantum Institute. This institute is only 1 year old. It will be 1 year old in March. And it all started when a number of countries approached CERN to say we are worried that the quantum computing will be extremely disruptive. It will have great opportunities, but potentially also a bit of risk. And we would like to do better at preparing our legal framework and a society than what we did for AI. I mean, if you look at the last 2 decades, disruptive technologies have had a big impact on our lives, and sometimes it was, you know, a bit disruptive. So, what OQI is a collaborative platform to develop quantum computing, but for society, for good, or for all. Let's go back in time a little bit. So, when AI arrived, or when GM Food arrived, there was no legal framework that was provided guardrail for the technology to develop in a direction that was beneficial for society. The way the states supporting this Open Quantum Institute have designed is to spread the technology as widely and freely as possible. So these are the values that we promote. So first of all, we absolutely value a partnership between the private and the public sectors. And this is something we touched on this morning on the panel. Now, of course, when you have actors from these two fairly separate fields, you need to find common ground for good collaboration. And the solution that we found was, let's focus our research and the applications of quantum computing on UN Sustainable Development Goals. As I said this morning, it's very hard to be against eradicating poverty, right? So when you have an application that is related to an SDG, normally this is very, let's say, non-confrontational when different actors work together. The other thing that are very important to CERN is that this is an open science type of initiative, which means that the technology and algorithm that is being designed inside the Open Quantum Institute is going to be shared. And is going to be shared in particular in underserved countries. So we would not like quantum to contribute further to the digital divide. So we make a very conscious effort to reach out to the part of the world where quantum is not yet established. We also believe that when you are developing a technology, you can also drive the focus of your developers on the application side, not just develop the technology and then look for application. So the way it works at OQI is that you come up with a problem related to an SDG that you would like to solve, and when it's onboarded, we put together teams so that the solution to this problem can be found. But because we're talking about SDG, we can't just rely on industry, university, startup. We also need people to validate that the problem we're trying to solve is actually worth solving. And that implies NGOs, UN agencies, and governments. So the teams are very diverse. So how does it work in practice? Because what we do is we take an idea all the way to a proof of concept implemented on a quantum computer. So the idea of the problem to solve, or the idea of the use case for quantum computing, is entered through our website. The condition for an idea to be onboarded is that it has to be related to an SDG, and it has to have some quantum advantage. When this is met, then you have the possibility to work inside the Open Quantum Institute. Two examples of the sort of project we are running right now. So on SDG climate action, with the UNDRR as endorser, if you like, we have a project running in Malaysia on providing better accuracy for the flood prediction. Right? So very applicable end result for a particular problem that is related to an SDG. In Lebanon, we have also a project running on the simulation of weather patterns in the use of water resources. Lebanon is a country where there should not be water shortages because there's a mountain range and you've got the sea. However, this is a difficulty they are facing. So again, we are teaming these teams of developers with UN agencies, and when they are developing the code, we assign an in-house OQI expert to mentor these teams towards the point where they can deploy the algorithms on one of our partners. So, as a summary, these are the opportunities that we can offer to the Saudi scientific community. Research and innovation for your faculty, your students alike, in a very wide range of fields. We have also internships, typically 12 months, in areas of high technology. We can even set up dedicated PhD programs. I can really recommend our summer student program. They're really having a blast, and it is like a teaser so that they can choose to dedicate their lives to research in science. And finally, something that the Saudi community could be wanting to do is to join our high-performance computing network. Thank you very much for your attention.